Hey, what's up? This is Madan here, and I have brought another very important topic from aldehyde, ketones, and carboxylic. Right? So let's start that topic nucleophilic addition reaction by aldehyde and ketones. So the first is mechanism of the nucleophilic addition. Nucleophilic addition. Right? So this is going to be the basic one. This is this is an aldehyde, and when you react an aldehyde with nucleophile, this is your aldehyde. This reaction takes place through a equilibrium process. So in case you understand that carbon is less negative than oxygen, then if you break the pi bond, oxygen will be receiving the electron. So this becomes a negative charge and your carbon becomes a positive charge. So what will happen? This being an electron rich, it will shift to the carbon. It will shift to a carbon with a negative charge also. So this will shift to the carbon. So this way you get carbon, a single bond, oxygen, and a negative charge, and you have a nucleophile. You have a nucleophile here, and the remaining two hydrogen or whatever they may be. So this is your intermediate. Now in the next step, what happens? This intermediate, capture a proton from the solution or the medium. This will capture a proton from the solution or the mixture, and then this oxygen converts into a hydroxide. So what you finally get, you get this product here. So this is the product finally you are getting. So this is the basic mechanism that I will do, some of the reaction which I am about to take now. But before that, we have to, I need to tell you that this first step of the reaction is a very slow one. This is a slow process, while this is a fast process. What that means? Protonation is a fast process, but addition to the nucleophilic is a slow process. Another very important thing, the structure of this carbonyl is trigonal planar. This is trigonal planar, right? Planar. And the hybridization is of course sp2. Now what happens once it changes into product? It changes into tetrahedral. Because the hybridization changes from sp2 to sp3. I hope you understand exactly everything I wanted to say. Right? Now the thing is that what are the reactions that follow this particular mechanism? That is where we need to concentrate. Right? So let's start the first example for this reaction. If you react an aldehyde, this may be, you need to remember, this may be aldehyde or this may be a ketone. Suppose there is cyanide here, which is coming from the hydrogen cyanide. So what will happen? This will form O, and with a negative charge, and carbon will develop some carbon which is a positive charge will come out with the negative. Right? In the next step, like I said, it capture a proton. Right? And then this carbon come out with hydrogen, and your cyanide is here. So this is called cyanohydrine. Right? So actually initially I was doing both steps together. Now you have as per your ncert, which I think you will easily understand that. Right? So this is the mechanism of reaction when aldehyde or ketone undergo addition with hydrogen cyanide. Right? There is more here. This entire reaction is slow. So let me write some statement here. addition of hydrogen cyanide, addition of hydrogen cyanide, if it's pure, is very slow process, is very slow process, and to make it faster, and to make it faster, a base is used as a catalyst. A base is used as a catalyst. So this is another very important. Let me repeat back. This process of aldehyde and ketones converting into cyanohydrin is entirely a slow process. To make this reaction, go sufficiently, speed up, you have to add a base, because that base actually act as a catalyst and make the reaction faster, to go faster. So this is the first one. Let's talk about the second example I can see. So what next is that when aldehyde or ketones react with the sodium hydrogen sulfide, NaHSO3, right? This is also a similar reaction, so it's a reversible. What happens when you break the bond? This was your second example. So this will break something like this, oxygen become negative, carbon become a positive. Now this is how the bond is broken, plus, and this become absolutely minus, right? Okay, now the thing is here that sodium will go with oxygen and hydrogen sulfide will go with the carbon. So what I'm going to do, placing this HSO3, and then you have your sodium here, ONA. Now what happened here, in the next step, proton transfer, H plus transfer. What the transfer mean here? Transfer means that sodium and hydrogen, they exchange their position, and if they exchange their position, if they exchange, I'm writing transfer right here, transfer of proton. So this is what kind of product is formed. This form, actually NaSO3, and there you have OH. So this also forms, a bisulfate, right? So this is the second example I could take. There is something theoretical here. If this addition takes place with aldehyde, the equilibrium remain in forward direction. Remain in forward direction. But with ketone, the equilibrium shift in backward direction. Now let me explain this. If you remember the very last topic, I was saying that an aldehyde is more reactive, but a ketone is less reactive. Why? Because a ketone has alkyl or aryl group from both sides, which causes steric hindrance, and because ketones are less reactive, therefore product formation is slightly difficult. And that's why if this is a ketone, formation of this product will be a bit slow, but if this is an aldehyde, the reaction is a bit faster because the equilibrium will be in the forward direction. Right? So now let's take the third example. Is that when aldehyde, this is absolutely about aldehyde. When aldehyde react with alcohol, a primary alcohol in presence of HCl. Then what happened? Like I said, oxygen will form a negative charge and carbon will form a positive charge. There you have, this OH negative and carbon as a positive. So what I will do? I will arrange them according to the mechanism. So R, C, you got O, right? R, C, O, R. This R has come with oxygen. Now, what will happen? This will form a OH. This will form a OH. And at the same time, you have a hydrogen. So I am placing them as something like this. Now, this product is called alkoxy alcohol. This is called alkoxy. Why this is? This is alkoxy. This is alkoxy. And this is an alcohol. So this is called alkoxy alcohol. Right? In the next step, this is again a video process. I am forgetting. Okay. So in the next step, you react with another alcohol molecule. So what happened here? Actually, this hydrogen is substituted by the alkyl group. Why? Because there you have your negative, there you have your positive. Here you have your positive. So this positive will displace the hydrogen, and therefore you get your product hydrogen, and this is called alkyl group. There you have OR, and there you have OR again. This product is called, this is called acetal. This is called acetal. While this is called, apart from alkoxy alcohol, this is also called hemiacetal. Hemiacetal. Right? So this is how the addition reaction with the alcohol take place. I hope you are understanding every bit of thing I am saying. We have another reaction that is going to be very important. So I am going to wipe this off so that I can take the fourth one. So the fourth one is is about a ketone. So I am taking a ketone this time. You probably understand that this represents to a ketone. So far, initial examples were about aldehyde, but this time it's about ketone. So what I'm doing right here, I'm reacting this ketone, with with vicinal, with ethane 1,2-diol. Let me write this: COH. COH. What this is called? This is called vicinal glycol. This is called vicinal glycol. Or you can write ethane 1,2-diol. I hope you understand. So what happened here during the reaction? Again this will form a negative charge. Oxygen become a negative charge. Carbon become a positive charge. So let's place them. You have two alkyl group here, as it was a ketone. Now you have a single one oxygen, and this oxygen will come out. Okay, now let's concentrate here again. If you break the bond here, this will go something like that. So OH come out as a negative charge. But there, what happened? This bond undergo cleavage. So this comes out as a positive. This is negative. This is your positive. So what I will do, I will attach this oxygen with the carbon, and this has a CH2. And on other one, you have again a CH2. This will be, again reacting with the carbon. So this form, this is called a compound. Ethylene glycol ketone. So ethylene glycol ketone. So this is what the reaction mechanism is. Now, in case you are willing to understand what happened to these two, of course you do know it forms a byproduct H2O. right? So this looks a bit different, this looks a bit complicated, but I would say, listen up, I'm taking 1 minute here. This looks a bit difficult or this may be a bit complex, but I feel like this is also interesting. So if you follow the process I do, that's going to be easy for you, right? So let's talk about the very last one, and that last one is, reaction with ammonia, reaction with ammonia or ammonia derivatives, right? So the next reaction is, aldehyde or ketone when react with, ammonia. This is called ammonia derivatives, right? So what happened when this bond will undergo cleavage? You understand probably, negative and a positive. Now you have to cleavage a bond right here. So nitrogen will be a negative and hydrogen will come out as a positive. So place this hydrogen with oxygen. Place this oxygen with along with the hydrogen. So you get oxygen with hydrogen and you get carbon with NHZ. In the next step, what happened? In the next step, this bond further undergo cleavage, and there this bond undergo cleavage. So this will come out as a negative, and the hydrogen will come out as a positive, right? So this will form H2O. Both of these combine and form H2O, and apart from that, you get another product, and this is going to be C, right? You get N, you get N and Z. So this is this is the addition product you get when you react aldehyde or ketones with the ammonia or ammonia derivatives. One very last thing I want to add about this reaction, that the addition. So these are some of the very important reactions, addition reactions of aldehyde and ketones, and they fall under the category of nucleophilic addition reaction, right? And you need to practice them because these are really important, right? So I must say, I have to wind this up because I'm very tired right now. I would say thanks for watching, thanks for your patience, and in case you liked everything I said, everything I did, what you need to do, show me, how you appreciate, and that's possible when you comment, right? So you have to do that. That is very important. It's not for you, it's for me, because that will, keep me helping, producing more and more useful videos for that.